Okay, first we are going to do in-class example number 4 to practice impulse. So this one reads, a billiard ball with a mass of 0.195 kilograms and a velocity of 0.85 meters per second to the right, so that should immediately tell you that this is positive, is deflected by the cushioned edge of the billiard table. The cushion exerts a force of 3.5 newtons to the left. So that should tell you that this number is negative because it's in the opposite direction. And the time that it is in contact with the cushion is 0.075 seconds. Question is, what is the ball's final velocity? Okay, so we're going to go ahead and use the impulse equation, which is mv final minus mv initial equals force times time. All right, plugging our values in. The mass is 0.195 times the final velocity is what we're looking for. And we subtract that from 0.195 times the initial velocity, which is positive 0.85. And that equals, this is where it gets tricky. Don't forget, it's negative 3.5 because it's to the left times the time that it's exerting that force over, which is 0.075 seconds. Okay, so when you do this math, what you want to do is combine the negative 0.35 and the 0.075. And so this part right here should get you negative 0.2625. And then you're going to combine this part, which, that's the bell, 0.195 times 0.85 gives you 0.16575 minus 0.195 VF, okay? You should have a fairly easy time solving it from here. You're going to add the 0.16575 over to the right and then divide by 0.195. Go ahead and pause the video here, do your calculation, do the right thing so you can learn, and then replay the video to see if you got the answer correct. The answer is, for B final should equal negative 0.496 meters per second. And that should make sense because the final velocity and the force have the same sign. The final velocity and the force have the same sign. Remember, we mentioned in class that the direction of the force is always going to be in the same direction as the final velocity. Okay? Now, you are going to spend some time working on this impulse practice problem, but let me help you out with a couple of the questions. First, number 1 is a fix-it, so make sure you fix it before you solve it. Number 2, direction matters. Okay, first of all, this 60-gram egg needs to be converted to kilograms, so do that first. The net force 1.5 newtons, that's your F. The time is 0.25 seconds. The S is over on this side. To bring the egg to a stop, what is the egg's initial speed? So it's very similar to the problem we did in class example number 4, except now instead of trying to find final speed, you're looking for initial speed. And then for question 4B, you're going to find the frictional force, which you will need by using the Fun equation here. Using the Fun equation, to find Fn, you're just going to find Fg. So here's your mass, and then you're going to multiply that by 9.8 to find Fn. You are given the mu, coefficient of friction. You're going to solve for the frictional force. Plug that in here. So this number will get plugged into that force to solve for time. That's what you're solving for in 4B. Okay, so take some time and through the impulse practice problems before you move on to the next item on your agenda.